Hello, everybody, and welcome to this session, to the October session of NAPA Tech Talks. My name is Peter McArdle. The session today is brought to you on behalf of NAPA Temp, your air conditioning supplier at NAPA Auto Parts. The topic today is we're calling Behind the Dash. In-dash issues or issues in the HVAC case that can cause an air conditioning performance problem. So what we're planning to talk about today is these are the topics we'll discuss. Trip to Texas with NAPA Echlin, some HVAC problem solving in the dash, air door actuators, HVAC case, some say HVAC case service tips, and also some blower motor and heater core diagnostic tips. And here is, this is a pretty big deal. We're offering with NAPA Temp, we're offering 10 seats. This is a 2-day hands-on class at our training center here in Irving, Texas. And the trip includes airfare, 2 nights hotel, all your meals while you're here, local transportation while you're here. It's a hands-on class. You'd probably spend half the time in the classroom and have the other half in the shop. Hands-on, they'll be held, dates to be announced in 2024. And we will be drawing the entrants, the contestant winners, after our December Tech Talk session. So don't forget to enter. Now, if you're watching at a shop, and there's 3 or 4 or 5 of you watching the one presentation at your shop, I suggest that you type in, if you have not personally registered for this session, I suggest that you type in your name, all the information that you see on the screen here, type it into the question box on the webinar interface there, and we will be sure that you get your that we enter your name in the contest. So go ahead, if you haven't registered for the webinar individually, be sure to enter your name and all the relevant information in the question box there of the webinar interface. Don't forget our website, the NAPA Temp website. Go to napatemp.com. There's some great technician resources there, all kinds of tech tips that you can download under the technician resources tab. Of course, you can look up, parts by year, make, model and see pictures and see different angles of pictures if you're trying to match up a part or see will the part fit or does it look like the one you're taking off and so on. Very useful resource. And also particularly useful if you look down the bottom in the red box down the bottom there, there is a link that says video library. If you click on that link, that will bring you to the NAPA Temp YouTube channel. And on there we have a whole series of great technical tech tip type videos. They're 3, 4, 5, 10 minutes tops long, some great technical information. In the context of today's conversation, I'd like to draw your attention particularly to 2 of them. Evaporator in the dash, evaporator leaks can be quite problematic to find and diagnose and identify. There are 2 videos on there. One is called dye leak detection. The other one is electronic leak detection. Some great tips on finding air conditioning system leaks and especially evaporator leaks. So highly recommended that you take a look there. All right. Don't forget to participate in our current NAPA Echlin promotions this October. If you purchase $250 worth of Echlin TPMS product from your local NAPA store, that will get you a free $25 Visa gift certificate. Next month in November, if you buy $500 worth of our Echlin product, we're calling it a winter tune-ups promotion. Coils, crank sensors, cam sensors, wiring cable, those ignition or traditional tune-up type of products. $500 worth of that will get you a $50 Visa gift certificate. So don't forget to be sure you're participating in our Jumpstart promotions in this month and next. And so that brings us right into the meat of the presentation, what we want to talk about today. The question that I like to pose, a vehicle comes in the shop, it's got some kind of an air conditioning or a heater system performance problem. It's not cold enough, it's not hot enough, or it's not defrosting properly. One of the first questions that I like to answer or try to figure out in my own mind is the problem in the dash? And what I mean by that is, you know, there's a lot of components in the dash, air doors, evaporator, heater core, and so on and so forth. There's lots of opportunities for things to be out of kilter in the dash. And, you know, typically it's a significant amount of labor to go in the dash. So I like to be pretty confident before I start working on it that the problem is actually in the dash. So I'm going to talk a little bit about some quick tips to really get you pointed in the right direction to determine, to satisfy yourself, is the problem in the dash before you begin. Now, these are simple kind of generic checks that, you know, they're pretty common sense checks to get the ball rolling here. Visual, you've always heard that. It's on every worksheet you ever read, probably. Start with the visual check, but it's amazing the number of times you open a hood and you look around and you see something disconnected or leaking or out of kilter right off the bat. Diagnostic trouble codes, plug in a scan tool, see if there are any, and be sure to scan all modules. Oftentimes, you know, if the transmission is overheating, the air conditioning is not going to work. So be sure you check for all trouble codes and see if any of them could be possibly connected to the system complaint that you're getting. AC head pressure, even without opening the hood, you can typically plug in a scan tool from the high head pressure transducer. You'll be able to see, you know, does it have at least enough pressure in there for something to start working. And you can even typically, with the bidirectional test, you can usually actuate just key on engine off. You'll be able to actuate the AC clutch relay. You'll probably hear the relay click and the clutch click. You know, quick, easy test to get you, you know, a sense of where where to start digging deeper. So that brings me to the HVAC case. Now, I think it's important to understand, you know, this is kind of a generic diagram here, but it's important to understand the path, how air typically enters and passes through an HVAC case. So of course the air is going to come in here through the fresh air. Most modern vehicles, of course, will have a cabin air filter. So if it's on fresh, it's going to come in from here. If it's set on recirc, it's going to come in. It's going to draw from within the cabin. Here's my recirc door over here. If I close it over there, it's going to draw the air. It's going to block off the fresh air intake. Going to draw the air from in here. If I close it over here, it's going to draw fresh air in through the cabin air filter. Blower motor, of course, is going to do its thing, draw the air in. And the next stop then is going to be the evaporator core. The air is going to pass or be drawn across the evaporator core. And I emphasize that it's regardless of whether it's winter or summer, hot or cold, all the air entering the cabin is always going to pass across the evaporator core. And that's important to understand, of course. Any restriction of the evaporator core is going to affect winter, summer. It's going to affect cabin airflow right off the bat. And the other reason, of course, that the air is drawn across the evaporator is that in the wintertime, when we go to defrost, we want to chill the air to dry the air to get the moisture to drop out. If we cool the air first, and then we reheat the air by drawing it across the heater core. So once we get past the evaporator, we're going to hit the blend door. Of course, with the dual zone system, it would have two blend door ports or passages in the ducting. But here we're going with a simple arrangement just for clarity. And you can see if the flapper's over here, the air is going to come around and come into the central plenum here. If the flapper's over here, the air is going to be forced to go through the heater, and it's going to heat the air to the desired the desired temperature, depending on whether the blend door is all the way across in either direction. Now I come to the, might have one or two blend doors depending on, mode doors depending on the system. And by opening and closing these flappers in the proper combination, I can either send the air out to the vent, to the customer's face. I can send it up to defrost or de-ice the windshield. And of course, I can send it down to the floor. If it's a cold winter day and I've already defrosted the window, I want some cold air at my feet, I can send it downstairs. And of course, I can set the flappers in between positions to, split the air between the face and duct and so on. So I've actually got an actual HVAC case on the bench here, and we're going to take a quick, look at that so that we can see, get a real hands-on sense of what's going on. I'm going to start here with a quick tip about, if you're replacing a thermal expansion valve. Most modern vehicles now, the thermal expansion valve is right in, it's right between the engine bay and the cabin inside the HVAC case. And a problem that you can run into, of course, this one here, this case, by the way, is from a Ford F-150, I think a 2010, 2011 Ford F-150. And you will see here that I've got two long screws. These are two long, think of them as dowel rods, right? And so when I take the first screw out, if I'm replacing the TXV valve, when I take the first screw out, I insert one of these long screws in here. And I screw it into the backing plate, the retaining plate that holds the TXV valve to the evaporator. And I use these long screws because have you ever had a circumstance where you take off the TXV valve, you remove both screws from the TXV valve, and then the plate can fall down inside the case, and now you're in trouble. So these screws are about 4.5 inches long. I think that's 11.5 millimeters, a 0.8 millimeter thread. Get them from the hardware store. I put them in a drill and I grind off the heads of them. And the advantage of that, of course, is that these will act as a dowel to prevent, like a handle to prevent the plate falling down inside the case. And also, when it comes to installing the new TXV valve, they can act as a guide to get it properly seated on the evaporator. The next thing is on this 2010 F-150, you can replace the heater core, of course. With that, you have to remove the case from the vehicle, but you don't have to take it apart. You don't have to split it to necessarily replace the heater core. And a couple of quick things. The one big message or takeaway that I want to get across from talking about HVAC case service is, when the air comes into the case, passes through the evaporator, passes through the heater core, passes by the various air doors, it's critical. It's absolutely critical that the sealing, that the evaporator, the foam sealing or rubber sealing, whatever it happens to be, it's critical that the evaporator core, the heater core, the blend doors, that all the components that control the airflow through the case, that they really provide a snug hand and glove sealing fit in the HVAC case. Now you see here, this is a demo unit that we've been here using, we're putting it in and out quite frequently. You can see how the foam has turned up here. So, if I were to install this heater core like this, air could easily pass by here. And I have seen many good air conditioning repairs. The shop has replaced the compressor, let's say. They've done the job by the book, but the customer's not quite happy. It's not as cold as it should be, maybe not as warm as it should be. And oftentimes that's because the evaporator core, the heater core, or an air door, one of the doors in the dash, is not a snug, airtight fit. Cannot overemphasize the importance of that. And of course, as vehicles age, this foam, these foams often, as vehicles age, the foam, deteriorates chemically, it crumbles and separates and so on. So you need to, I know on some of our heater cores, we actually supply additional sealing foam in the box with our heater cores. And I'm just emphasizing that if you have a problem with foam sealing, there's no sense in putting the heater core, the case back together until you take care of that. So I'm going to separate, I've taken all the screws out of this already. So I'm going to separate the case here and put the top half on one side and just really review what we just looked at on the screen on our diagram a moment ago. Blower motor is going to be over. Let me just tip it up a little bit. The blower motor, of course, is going to be over in this direction. Air is going to come in here. It's going to be forced. Note that it just has to come through the evaporator. That's why, the evaporator has got to be a hand and glove fit inside the HVAC case. Now, here is the blend door in this particular case here. And in this particular case, the blend door is actually particularly tight. Okay, and that was actually a problem with this case. So, if you're replacing an air door actuator, it's very important that, whatever door it is, that you check for free and clear and easy, smooth movement of the door through the full length of its travel. So here, if I put the blend door here, the air is going to come through the evaporator. It's going to be forced to go around through the heater core. So this would be the heat setting. If I put it over here, it's going to block the heater core. The air is going to come off the cold evaporator, come straight through here into the central distribution area. Now, if you remember, I started the conversation by suggesting one of the things that I want to do is really early on in my diagnosis, I want to satisfy myself, is this problem in the dash or is it not? Could it be a basic refrigeration system problem, maybe a problem with the compressor or the, cooling fan or something of that nature? So a quick test that I do is I'm going to, this is the suction line coming out. It's going to be coming out of the firewall here. I'm going to put a temperature probe. I use a dual channel temperature probe. You'll see a picture of it in the presentation. I put a temperature probe here on the suction line outlet, and I put another probe in the dash, in the center duct of the dash. And so in other words, I compare suction line temperature to duct air temperature. And so if I see that the suction line temperature is maybe 37 to 45 degrees, pretty low, pretty normal, but the duct air is 60, 65 degrees or significantly higher, more than 10 degrees, let's say, more than 10 degrees higher than the suction line temperature, that tells me right off the bat that my problem is in the case. It's in the dash. I mean, if the suction line is cold, that means the evaporator is cold, the basic refrigeration circuit is doing its job. That tells me that the problem is in the dash right off the bat. Now, whereas if the duct temperature is high and the suction temperature is high, that means, that the evaporator is a higher temperature than I would expect. And more than likely, then you're looking at a refrigeration circuit issue like low charge, weak compressor, condenser airflow, something of that nature. However, there are two exceptions. If suction temperature is high and duct temperature is high, there are two other things to check to eliminate a problem in the dash. And they are the recirc door, because if the recirc door is stuck open, hot air coming from the outside is going to impact the evaporator, and that will drive up your suction line temperature, and of course it'll also drive up your high side pressure. The other problem is if the system is set on recirc and you're drawing air from inside the cabin, and you've got a blend door issue where some air is bleeding across the heater core when it's supposed to be set to cold, that will obviously, the air blend door will be, the duct temperature will be warmer, and it will also raise your suction line temperature, because that puts excessive additional heat load on the evaporator. So let's go back to the presentation here for a minute, and we'll take a look at a couple of other perspectives. So let's suppose, my testing has determined that the problem is in the dash. Naturally, if the problem is in the dash, then any one of these components, some combination of them could be. There are lots of components and issues that could be centered in the dash. So let's start digging into some of these systems and see, can we figure out some diagnostic tips for each of these aspects. So as I said, this is the dual channel temperature probe I talked about. It'll clip onto a line very easily. You can clip it into the dash, and it'll tell you, the temperature of the two probes. And a really neat thing about it is on the bottom reading there, it tells you the difference in temperature between the two probes. As I said, I don't like to see more than, ideally less than 5, but definitely not more than a 10-degree difference in temperature between the suction line temperature and the dash temperature. So that's my first approach to determine, is the problem in the dash, or is the problem with the basic refrigeration circuits out under the hood somewhere? So, so that's why, internal case sealing, as I mentioned, is critical. Now, you may remember, of course, we talked about blend door issues. Most modern air conditioning systems use what we call a free flow or an open flow heater core. In other words, there is no heater valve. In other words, hot coolant courses through the heater core all the time, even on a hot summer day. So that's another reason why the foam and the sealing and the blend door, the whole air pathway through the dash has got to be very tightly and carefully sealed, because if you've got bleed past any of these components, it's going to affect your air conditioning, it's going to affect your cooling. So, in a good way to isolate, either if it's a free-flowing heater core with no heater valve, or even if it has a heater valve, my recommended procedure for isolating the heater core, whether it's a blend door problem or a heater valve problem, best way to do that is to completely isolate the heater core from the cooling system. And as you can see in the picture here, I've installed a little U-tube loop to temporarily bypassing the heater core. If you're planning to, I don't like crimping, especially older heater core hoses. I don't like crimping them off, but of course they do make crimping pliers. You see them in the picture there. And especially if you're planning to replace the heater cores, you could, the heater hoses, you could certainly crimp them off using the proper set of pliers. The one thing I do recommend is that you isolate the heater core when the vehicle is still cold. This way, because if you wait until the system is hot to isolate the heater core, now you've got to wait for the hot heater core to cool down. It can take a half hour, maybe even more, for it to really cool down sufficiently to give you enough indication that the problem is in the heater core. So isolate the heater core when the engine is off, when it's still cold. So let's jump into air door actuators. Simple, you know, they're on paper, they look kind of simple, bidirectional motors. You've got the mode door, of course. The mode door, of course, controls whether the air is sent up to defrost, whether it comes out the vent or down to the floor, or some combination of the above. The temperature blend door, and of course, you know, that's what mixes the cold and hot air to give you the desired duct temperature. And the recirc door either forces the air to come in from the outside or recirculate from within the cabin. And most vehicles, especially if it's if it's got rear air or it's a Suburban or something of that nature, 3 to 6 actuators per vehicle is pretty common. So jumping into the circuitry and the way these motors are controlled, this is probably the simplest circuit out there. It's just think of a small, tiny power window motor. It's a 2-wire bidirectional motor. If I put power on one side and ground the other to go in one direction, reverse the polarity, it goes on the other. It's got no feedback or position sensor, anything of that nature. This type of door is often used for the recirc door. And the computer just drives the motor for maybe 5 or 6 or 10 seconds, and it says after 10 seconds that recirc door should be absolutely closed or it should be absolutely open, and it stops. It just turns it off. It doesn't try to sense where it's at. It just pushes on it for what it knows is long enough that it should be closed or should be open. There are 2-wire motors. Typical 2-wire motors used a lot on Chryslers and Dodges. They're simple. Again, 2-wire motors. You reverse the polarity to reverse the direction of the motor. But these motors do have feedback. But the feedback piece of it is kind of built into the HVAC module. The module will either the waveform, the current. If you were to look at it with a micro amp probe, you would see the patterns in the current waveform. So the module will often count the pulses in the current waveform. And then when it gets to the end of its travel, of course, when it jams it up against the stop, you get a significant increase in current. So when the computer sees the current increasing, it knows the air door is at the end of its travel in that direction, reverses in the other direction. It counts the pulses in between. And this way, the computer knows exactly where these air doors are at. This is important, for proper temperature control, especially on the automatic climate control systems. The computer needs to know exactly where all these different doors are at. This setup here is used on a lot of GM and Chrysler products. As you can see, there's a 3-wire sensor in there, just like a TPS. I'm sure you're familiar. Don't have to explain that to you. 5-volt reference ground signal. You can check it very easy with the scope. It'll sweep back and forth with an oscilloscope. And the other thing I do want to point out here is the control circuit. You see it's got battery powered. There's a little electronic circuit board in here. It's got battery voltage going in. And then this is the actuator control circuit. If the module puts 5 volts on that wire, the motor would start turning clockwise. If the module grounds that wire, the motor would start turning counterclockwise. And if it puts a steady 2.5 volts on that wire, the motor would just sit right there where it is. So that's how the computer controls the positioning of these air door motors. Now, you can certainly, if it uses a position sensor type of circuit, you can put an oscilloscope on there and sweep it just like you would do a TPS. And especially if it's an intermittent problem, maybe it sets a code once in a blue moon and you're trying to get a handle on it, it's an intermittent issue. Putting a scope on there can often give you enough information. Even though it's not setting a trouble code, you may see enough ripple or disturbance in the signal to tell you that there's a problem with that particular actuator. And of course, again, going back to how I set the table for the conversation, I do not want to be going in the dash unless I'm pretty confident that the heating or cooling issue that I'm trying to fix is in the dash. So hopefully I've given you some clues already to get you pointed in the right direction, pointing toward the right answer to that question. So some quick air door actuator installation tips here. Never plug in an actuator and never plug in an actuator and just turn the key on with the actuator flapping, hanging in the breeze, because when you turn the key on, a lot of systems, excuse me, a lot of systems will put the actuators through their calibration cycle just by themselves, and if the motor's not mounted, it can go off the end of the normal travel range inside the motor. It'll grind up the gears, mess up the sensor, and so on. You never want to allow a motor to move without it being mounted. And just to reiterate, going back again, you see some of the pictures in what we're looking at here. You can see those foam panels again. Again, that foam ages, sloughs off, and you get air sealing problems. It's important to check that the doors move freely and that the sealing up against their stops. Now, to emphasize, to kind of reiterate how important this is, here's an old TSB. It's been around for years. You've probably seen it before. It's a GM TSB. Usually the vehicle will come in with a ticking noise in the dash, or maybe setting air door over travel codes. What I want to draw your attention to, and the fix for this issue is a flash update for the HVAC control module. Now, why I'm emphasizing this, I want you to look at the values here. It loosens up the commanded versus actual position to make it less likely to set a trouble code. But look at the bottom element there. The bottom thing, the bottom value is called crush time. That is the length of time in seconds that the control module tries to, turns the motor on and bullies it, pushes it up against the stop at either side. And you see what the update did is it reduced the crush time from 2 seconds to a half a second, to 0.4 of a second. And the reason for that is, as the vehicle ages, that foam we talked about kind of consolidates and shrinks and gets harder. So there's not as much puffiness to it. And so that's what can cause the air door to over travel. So that's why they've reduced the crush time to significantly by, over a second and a half. And I emphasize this because I see a lot of inexpensive air door actuators. They can't withstand the stress of that crush test, and they either set a trouble code or the strips the gears inside. It puts the motors under significant stress. So it's important that when you're replacing actuators that you use a quality piece. So the next thing we're going to do here is, I've got a vehicle set up. We're going to do a live air door recalibration. I've got it set up on it's a 2015 Chrysler 200. And as you can see from the screen here, I've actually got it at the air door recalibration screen. If you've replaced an air door actuator, it's important to do this air door calibration test. I will also point out, there's another test on here called the HVAC cool down test. It's built into Chrysler systems. It will perform a performance test. It looks for a specific temperature drop at the evaporator. It goes through a routine, looks for a specific temperature drop at the evaporator to check, is the system within the performance parameters that Chrysler expects. But for today's test, I'm just going to do the actuator calibration test. And this test will move all the HVAC doors to the full travel limits. Now, I'm emphasizing this to you. You need to do this after you install a new air door actuator. And I find this feature on a scan tool particularly useful for finding intermittent air door actuator issues, especially if it's the position sensor type. I can put my scope on the position sensor signal somewhere along the way at the module, at the actuator, wherever I can get to it. And by driving the air doors back and forth through their full cycle, and also putting that pressure on them, that crush time at either end, oftentimes it'll either set a trouble code, or I'll see some indication on my oscilloscope pattern that there's a problem with that particular air door actuator. Great for finding intermittent problems with air door actuators. So now it's actually, the test is in progress. It's driving the doors back and forth, so shouldn't take too long here, and it'll come back with the result. There is one thing I do want to point out in the result that could be a little bit confusing in some circumstances. And it's important to do this test so that the computer knows where all the doors are at, so that it can control where the air is flowing, the temperature of the air, and so on. It's important to perform this test when you replace an actuator. So you can see, you see that there's 4 results here. and it's all have passed, they're all true or passed, except one. And it says Actuator 2 right temp calibration pass flag. We're working on a 2015 Chrysler 200 today. It does not have automatic climate control, so it only has one air door actuator. So the system, the module is set, it doesn't set a trouble code for it, but it is set to receive the extra input from a dual zone, a right side, a second air blend door actuator. It didn't receive that result, so that's why the result there is false, but that's perfectly fine. The rest of the software knows not to expect that signal, but just wanted to point out that that's where we're getting the false reading there, is because it is not a dual air system, doesn't have a second blend door actuator. So we're going to exit out of that for a minute and let's go back to the presentation. And we're going to talk here a little bit about some HVAC service tips. There's a quick tip for 09 and later Ford F-150s, for example. Customer will often come in and they will have one or two or both complaints. They would say the air conditioning is not as cold as it used to be. And also an observant customer might notice that the airflow from the duct is not as much, it's not as strong as it used to be. And of course, the problem here is, as you can see, I think pretty clearly in the picture, the problem here is that this vehicle does not use a cabin air filter, and the evaporator is all clogged up. It's all, it's stuffed up with debris, dog hairs, and so on. Now, a quick check for this. So your vehicle comes in your shop, here's a quick tip to get a handle, to get pointed in the right direction for this problem. Plug in a scan tool and look at evaporator fin temperature, evaporator core temperature versus evaporator target temperature. If the target temperature and the actual temperature, evaporator temperature, are both low, usually less than 40 degrees, 37, 38, 39 degrees in that window, so if that tells me that the evaporator is actually cold, but the air is probably bypassing it or getting around it because the evaporator is clogged. And so if the evaporator, if the temperature on the scan tool is cold, less than 40 degrees, but not cold coming out the duct, or not cold enough, or not enough of it coming out the duct, at least the problem's definitely in the dash, and you will need to take a borescope and check the evaporator core, or your problem is going to be in the dash for sure. And so now, if you determine that the evaporator core is in fact clogged with debris and so on, now you have to make the decision whether or not to try to clean it, or whether to take the whole case out of the vehicle, separate it, and replace the evaporator core. My personal experience, we do a lot of relationships with shops here in the DFW area, pretty hot air conditioning environment, and 9 times out of 10, most guys tell us that they replace the heat. They take the case out and replace the evaporator core, because you can try cleaning. You might have some what we would call partial success, but usually the customer's back fairly quickly and with the same complaint. So it's often more just from the get-go to just replace the evaporator right from the get-go. The other thing I would point out here, that if you go back to Ford for this solution, oftentimes you have to buy the entire HVAC case, that with the actuators, the heater core, the evaporator core, with all the components of $400, $500, $600, $700 I've seen in some instances. You can probably take this out and replace the heater core, the evaporator core, and the actuators yourself in your shop, and for probably half the price, and still be quite profitable. In other words, offer your customer the same value as a new case for half the price. A quick tech tip here. Again, I'm looking for direction. Is the problem in the dash? Is the problem out under the hood in the with the basic refrigeration system? If I look at my scan tool, evaporator target temperature, if the target temperature is 35 degrees, but the actual temperature is 65, 70 degrees, then the problem is probably a basic refrigeration circuit issue, undercharged compressor and so on. The problem is not in the dash. And so that brings me into a discussion of heater system diagnosis. These are some quick guidance tips for heater core diagnosis. If I'm looking at the inlet hose to a heater core, it should be at working temperature. Obviously, look at the thermostat, look at your scan data. You know, a working vehicle, temperature is going to be up 200 degrees plus. And I'd expect the temperature of the coolant entering the heater core to be close to engine coolant temperature. Certainly 195, probably actually 200 or better in most cases. And I'm expecting probably a 35-degree drop. I mean, if I'm shedding heat in the heater core, I'd expect probably about a 35-degree drop from the heater core inlet to the outlet. So I want to see a 35-degree drop between the inlet and the outlet. And the air, if I just measured the temperature of the air coming out the center duct, I'd expect the air temperature to be 135, really ideally 140 degrees or higher coming out the duct to tell me I'm getting I'm getting the temperature that I would expect for a nice, warm, cozy cabin. If I see a large temperature drop across the heater core, hot going in, but it's, kind of very cold or cool coming out, then there's probably no flow. The heater core is probably all blocked up. You've got no flow. On the other hand, if it's hot going in and hot coming out, only a few degrees of temperature drop across the heater core, then it's not blocked. You're getting a small flow through, but it's mostly blocked and you're not shedding any heat inside. It's probably a significantly restricted heater core. The other thing I want to, of course, oftentimes when you're about to replace the heater core, the reason that you're replacing it is because it's got a leak, right? And that's why I want to talk a little bit about cooling system chemistry. If you were to roll out the interior surface of any cooling system, of a specific vehicle cooling system, you'd see there's rubber and brass and aluminum and steel. The composition of the different pieces of the cooling system between engine and so on, all kinds of different metals and materials and different surface areas of them. So that is why OE manufacturers, you walk into the part store, there's 7, 8, 9, 10 different antifreeze options. And that's because OE manufacturers choose their antifreeze chemistry very carefully to match the materials in the cooling system and reduce the buildup of acids and other, mischievous chemicals in the system over time. And in fact, think of antifreeze as a wearing part. It gets consumed, used up. It's designed to be used up as the vehicle ages. So that's why it's important to service the cooling system frequently. You can have corrosion, electrolysis, and of course erosion. These are the 3 typical modes of failure. If it's corrosion, most systems, if the system hasn't been serviced and flushed, the antifreeze ages, deteriorates, it gets used up, and you gradually over time, especially if air gets in there, you get a buildup of acid in the cooling system, and that's what can cause your heater core to leak. And of course, the best way to check for the condition of cooling is to use, I'm sure you're familiar with those coolant test strips, and depending on the change of color, it will give you a good indication of the chemical balance of the cooling system. Now, electrolysis, there's 2 types of electrolysis. There's chemical electrolysis, which is usually due to that chemical deterioration of the cooling system as the vehicle ages. And then you can have electrical electrolysis, which is typically caused by a grounding issue. The chassis is not properly grounded to the block, or you have a grounding issue between the chassis or the engine and the battery negative post. And so current flow starts up and tries to start flowing to the heater core, sets up a chemical reaction, and it eats a hole through the side of the heater core. You can check for that, by measuring the voltage difference between the coolant and the negative post of the battery. That's how you would check for electrolysis generally. Of course, as the system ages, you can get aluminum oxide, little hard particles building up, and other rust and debris building up in the cooling system. As that debris courses through the system at a right angle, let's say at a heater core or an elbow in a coolant fitting, that can literally wear a hole out through the side of the line. And so for that reason, if you find with your coolant test strips that there's significant chemical, it's very acidic, you really need to neutralize your part store will have some kind of a neutralizing product. You need to neutralize the acid base in the system and thoroughly flush it out. Otherwise, if you don't, you're going to have a repeat heater core failure. And a bit like the evaporator discussion earlier, this particular slide here refers to, I brought it in, it came from another presentation about 2012 to 2014 Honda CR-Vs. the heater core gets all scaled up inside. The Honda solution is to use the CLR product, a sump pump, and it's a long, involved 3-4 hour process to try to flush the evaporator to remove the scale. I personally find that it only works some of the time, might work decently on younger vehicles, but as the vehicle older, it's not nearly as effective. And also using a pretty strong chemical here. I've seen several instances where you go through these hours of flushing and then you end the chemical has caused, you have a leaking heater core when at the end of the process. So typically, often it's better to just replace the heater core right from the get-go. And of course, if you have serviced the cooling system, I've replaced the heater core, it's important to use a vacuum fill tool to properly bleed air from the system. The heater core is typically the highest point in the system, so it's important that we get all air bubbles out of the system. Don't forget to crack that bleeding screw, typically located on top of the thermostat housing. You want to bleed all air out of the system. So that jumps us into blower motor service. Most vehicles today are using a cabin air filter. A quick cabin air filter tip here is, have you ever taken out a cabin air filter, debris falls down into the blower motor, and then somebody turns on the blower, that debris gets blown up into the dash, into the ducts, and creates noise and so on in the dash. Quick tip here, a lot of blower motors are not too difficult. Oftentimes, take out one screw and give it a half of a little turn, and the blower motor will drop right out. Sometimes, if it's easy, take out the blower motor before you take out the cabin air filter. That way you can catch the debris on the floor of the car rather than it falling down into the squirrel wheel of the blower motor. The other thing, and I really emphasize this to you, I've seen lots of cases where the replacement cabin air filter, it was creating significant restriction to the airflow. And so the customer came in with the complaint, the old air filter was dirty, and they replaced it with a certain type of air filter that was causing as much restriction as the old one. So just watch out for that. If you use a manometer, airflow meter, you can check for that concern. That brings us into blower motor resistor, blower motor circuits. Blower motors take a lot of current. I mean, a blower motor consuming 25 amps at 14 volts, that's 350 watts. That's as much current, that's as much horsepower as a small tabletop microwave oven. And you can see the impact it has on, for blower motors pulling too much current, you can see what it can do to a blower motor resistor there. Just on that same point, most customers actually run their air conditioning. You don't have it on high all the time. Most people run their blower motor on 1 or 2 position, maybe 3 sometimes. And when you're on 1 or 2, the blower motor resistor is the electrical component in the circuit that's doing the lion's share of the work. And you can see here, at positions 1 and 2 in a typical GM blower motor circuit, the resistor is doing, 60, 70, almost 80% of the electrical work in the circuit. And I've actually used an infrared camera here on a blower resistor. You can see it's 536 degrees. So, again, it's very important to think about the blower motor resistor, and the pigtails for the resistor and the blower motor. Think of them all together, because a problem with one can impact the other. And so, excessive current draw in the blower motor circuit, oftentimes, the customer comes in with the concern, and you find the connector at the pigtail, at the resistor, or at the blower motor, or at the control knob, the terminals are burned, and that's because this circuit carries a lot of current. And so this is one we had here at the training center recently, 14 volts, 27 amps, that's 378. We're nearly at 400 watts. That's a lot of heat energy being dissipated through that blower motor resistor. And so the advice to you here is, if you have a blower motor concern, the blower motor has failed, the resistor has failed, any evidence of burning in the circuit, we sell the complete kits that includes the blower motor, the pigtail, and the resistor, especially for problem vehicles where we find high numbers of repeat resistor connector failures. And oftentimes, the resistor failure, in fact, 9 times out of 10, the resistor failure is caused by excessive blower motor current draw. So at the very least, you should take an amp probe and check the blower motor current draw. Quick tech tip here, 2000, these 08, I think, to 012 Ford products, they can come in blowing warm, not AC, not working as well as it should. High side pressure, 350 PSI. You might recover, recharge. The customer takes the vehicle, works great, comes back 2 weeks later, same problem. Well, believe it or not, the issue, the root cause of that problem is the low speed on the blower motor resistor is burned out. And so the compressor runs, the evaporator is ice cold, but there's no heat load because there's no airflow, and the low side of the system goes into a vacuum. The suction line goes into a vacuum, draws air in past the front seat of the compressor. And so the cycle, if you don't catch it, if you don't understand that the blown resistor or even the test for it, it can cause repeat. It'll go out, work well for a couple of days, and come back a week or so later with the AC head pressure 350, 400 PSI because of a blown resistor. So before we go, we've already touched on several times, going in the dash, it can be very time-consuming labor. Oftentimes it can result with shakes and rattles and rolls, problems inside the dash after it's been reinstalled. So you definitely do not want to be going in the dash more than is absolutely necessary to replace any of these components. So two things I would emphasize here: consider replacing whatever components, have a reasonable, rational conversation with your customer. I would recommend, if it's a 5-6 hour labor and even more job to replace the dash, I'm going to replace any components that would make sense, that if they fail, I'd have to take the dash back out again. And of course, the other thing I'm going to want to do is choose a quality component. Now, for example, if I have to take the dash out to replace an actuator, air door actuator that requires me to take the whole HVAC case out of the vehicle, I'm going to replace at least all those actuators that where I would have to take the dash out again. And in fact, recently we just, in the past year or so, we've introduced these actuator service kits. So they come 3 or 4 depending on the particular application, where you get all the actuators in one box for the particular application. And if you're taking the case out of the vehicle, it just makes a lot of sense to replace all the actuators. You're saving yourself and probably your customers some grief down the road by replacing all the actuators at the same time. Actuators, when you look inside, if you look at the one on the screen here, they're pretty complex. They're pretty complex drive gear set inside. Remember, they're very closely monitored by the computer for current spikes and position, voltage, and so on. They're precisely engineered components, and they're very closely monitored. Look at all the trouble codes that can set in relation to a air door actuator. And this is a scope pattern here. I think it illustrates a couple of things that I want to draw your attention to, and why it's really important to be sure you choose a quality air door actuator. The blue pattern on the bottom is the voltage, just like you're sweeping a TPS. That's the voltage, the position sensor pattern as the motor goes back and forth from end to end. And the top, the red pattern there, that is my that is the blower motor, the air door actuator current. And I want you to note here that, it is the crush time. What I want you to look at is the crush time. This is the length of time. It's 4.5 seconds here, 12.5 seconds here. This is the crush time. This is the length of time during the recalibration setup that we just done on the Chrysler here. That's the length of time that the computer is literally stall talking the motor to set the travel stops as part of the recalibration process. It takes a good motor that can withstand that kind of strain, that's been torque tested and so on and so forth. The recalibration process, I find, is great for finding intermittent problems, and especially if you use it in conjunction with the scope, it's great for getting a handle on an intermittent air door actuator issue. And so we do a lot of testing, dimensional checks, temperature cycling. We do a tremendous amount of cycling we stall test the motor 8,000 cycles as part of the manufacturing regimen as the pre-production setup and validation testing of our air door actuators. We do torque testing, the current wave pattern and so on. We want to be sure that when you take that air door actuator out of the box, it matches and mirrors exactly what the control module, what the software and the HVAC control module is expecting to see coming back from that motor. So, and this is the ones I had in my hand here just a moment ago. You can see how the gear, the OE gear on the left, the plastic cracks because it's a metal plastic combination gear. We've re-engineered that gear with it's an all, it's a one piece gear, all plastic gear, completely eliminates that cracking issue. That's just one example of where we've looked at what the pattern failure is on the original, and here's what we've done to eliminate that issue. So the end result, of course, is powerful, reliable, durable air door actuators. That's what we plan to put in our boxes. So that brings me to the end of today's session. Don't forget to enter for the Trip to Texas contest. This phone number, we have an air conditioning, heating, temperature control tech line here in this building at our training center. It's a toll-free number. And because you're in NAPA is a big customer of ours, they get preferred customer status. That PIN number there, 59017. In the summertime, it gets pretty busy here. You might have to leave a message and wait for a call back. By using that PIN number when you call in on the menu, you will get a much faster. They may even answer the call live, or you would certainly get a much faster call back if you have to call in here during the summer. So that's if you have a technical air conditioning problem, heating system problem, or a part problem. If you're trying to match up a part, or you're looking at an old vehicle, or you're trying to match up a particular part, oftentimes the guys here on the tech line will be able to help you answer those questions. So with that, I will wrap up our session for this afternoon and see, do we have any questions, Corey? We're all clear. Thank you for joining us. Don't forget to join us for the December session. That's on December 7th. We will have a session at 12:15 Eastern and another one at 12:15 Pacific. So they are our December sessions. The topic is winter tune-ups, cam sensors, crank sensors, ignition coils, traditional tune-up type of territory. So until December, take care, and we will see you then. Thank you.